Hi, today I will talk about intermolecular forces. You might wonder why physical properties differ between substances, such as the melting points of solids and boiling points of liquids. These properties are determined by forces called intermolecular forces. Intermolecular forces is forces that occur between molecules. For example, dipole-dipole forces and hydrogen bonding.
Now I will talk about dipole-dipole forces.
What does dipole means?
Dipole is a polarized molecule having partially positive and negative poles.
What does dipole-dipole interaction means?
Dipole-dipole interactions are a type of intermolecular attraction, attractions between two molecules. Dipole-dipole interactions are electrostatic interactions between the permanent dipoles of different molecules. These interactions align the molecules to increase the attraction, which means those atoms that are more electronegative pull the bonded electrons closer to themselves. Molecules with dipoles that are not cancelled by their molecular geometry are said to be polar.
How does dipole-dipole interaction occur?
This is a good question. Dipole-dipole interactions result when two dipolar molecules interact with each other through space. When this occurs, the partially negative portion of one of the polar molecules is attracted to the partially positive portion of the second polar molecule. Example of a dipole-dipole interaction can be seen in hydrogen chloride, HCl. The relatively positive end of a polar molecule will attract the relatively negative end of another HCl molecule. The interaction between the two dipoles is an attraction rather than full bond because no electrons are shared between the two molecules. Two hydrogen chloride molecules displaying dipole-dipole interaction. The relatively negative chlorine atom is attracted to the relatively positive hydrogen atom.
Last question, what is the relationship between the boiling point and dipole-dipole forces?
This type of interaction between molecules accounts for many physically and biologically significant phenomena such as the elevated boiling point of water.
Thank you for this information.
You are welcome.
Now I will talk about hydrogen bond.
Hi, can I ask you some questions?
Yes, you can.
What does hydrogen bonding means?
A hydrogen bond, often informally abbreviated H-bond, is a primarily electrostatic force of attraction between a hydrogen atom which is covalently bound to a more electronegative atom or group. Especially the second-row elements of nitrogen and oxygen, or fluorine.
What are the types of hydrogen bonds?
The first type, intramolecular hydrogen bonds, are those which occur within one single molecule. This happens when two functional groups of a molecule can form hydrogen bonds with each other. In order for this to happen, both a hydrogen donor and a hydrogen acceptor must be present within one molecule, and they must be within near proximity of each other in the molecule. For example, intramolecular hydrogen bonding occurs in ethylene glycol between its two hydroxyl groups due to the molecular geometry. Second type of hydrogen bonds is intermolecular hydrogen bonds exist between different molecules in a material. They can occur between any number of like or unlike molecules as long as hydrogen donors and acceptors are present in positions where they can interact with one another. For example, intermolecular hydrogen bonds may occur between ammonia molecules alone, between water molecules alone, or between ammonia and water molecules.
What factors can preventing hydrogen bonding?
There are three factors. First of them, electronegativity. Hydrogen bonding cannot occur without major electronegativity variations between hydrogen and the atom it is bound to. All atoms that have an electronegativity of 2.1 and no dipole moment exists. This prevents the hydrogen bonding from obtaining the partial positive charge required to hydrogen bond with the lone electron pair in another molecule.
Second, the size of donors and acceptors will also affect the ability to hydrogen bond. This may account for the comparatively poor ability of chlorine to form hydrogen bonds. When the radii of two atoms vary greatly or are large, their nuclei cannot reach close proximity when they interact, resulting in a weak interaction. Third, donors and acceptors. In order for a hydrogen bond to exist, there must be both a hydrogen donor and an acceptor present. The donor in a hydrogen bond is typically a highly electronegative atom such as nitrogen, oxygen or fluorine that is covalently bound to a hydrogen bond. The hydrogen acceptor is an electronegative atom of a neighboring molecule or ion that comprises a lone pair that participates in the hydrogen bond. This is valuable information, thank you. You are welcome. There are many differences between dipole forces and hydrogen bonding. Can you compare them? Yes, we can.
In dipole-dipole forces we will see positive and negative ends close to each other.
In hydrogen bond there is atoms with high electronegativity bound to hydrogen.
It's only about 1% as stronger as covalent or ionic bonds.
It's strong dipole-dipole forces and it's have important effect on physical properties such as boiling point.
It has inverse relationship with the distance between dipoles. When the distance increase it will be weaker and vice versa.
High electronegativity and small size means strong hydrogen bond.
Thank you. In conclusion, intermolecular forces are electrostatic in nature and include van der Waals forces and hydrogen bonds. Intermolecular interactions are weaker than intramolecular interactions. All the transitions between solid and liquid or liquid to gas depend on changes in intermolecular forces, not intermolecular interactions. We have reached the end of the video. Thanks for watching. Goodbye.